practical hands-on demonstrations of how to get started in 3 different ways with Cockroach DB. First being with a downloadable binary that is available via our website. The second way we're going to look at is by deploying inside of a Docker container or a set of Docker containers. And the third way we're going to look at is by installing using an orchestration tool called Kubernetes. So those are the 3 things that we're going to look at today. In terms of myself, my name is Daniel Holt. Some of you may have seen me on previous webinars, but my role at Cockroach is a solutions engineering director. So I very much sit on the technical side of things. So please feel free to use the QA panel and the chat box to ask questions. I'll try and keep an eye on them as I go through the demonstration, but there will definitely be time left at the end for me to go and answer some of those questions for you. So please use those facilities to ask questions as they come up. So I told you there wasn't going to be very many slides, so that is literally all of my slides done. So let's get started with the demonstration. First thing we're going to do is we are going to install Cockroach DB locally on my laptop using the downloadable binary from Cockroach DB. I'm not going to sort of go into how you download the binary. It's very, very easy. You go to the website, you download the binary using a command, and that is pretty much it. But what we will go through is each of the parameters that we're going to use to actually start Cockroach DB. So in my Visual Studio Code window on the right-hand side, you will see that I'm going to start the first node in the Cockroach DB cluster. And it's important to note that every Cockroach DB cluster has a minimum of 3 nodes for it to be a viable sort of production or even a test harness for us. We really don't recommend anything less than 3 nodes, because if you're looking at Cockroach, you're looking at us for resiliency, scalability, and you really want to be starting with 3 nodes. So to start a node with Cockroach DB, it's very, very simple. There's just a cockroach start command, and then there are a number of flags beneath that we're going to go through. So in this case, because it's a demo test environment, I'm going to start the cluster in secure mode. What this allows me to do is get a cluster up and running very, very quickly without have to worry about, signing certificates with certificate authorities and things like that. In production environments, you will definitely not want to do this. You will want to just not include this flag, which by default will put you in secure mode, and then you will have to pass in directories for your certificates and things like that. The second flag here is the store --store. And what that actually is just a directory of where we're going to store all of the data that gets stored inside of Cockroach DB. In this case, it's going to store in my current directory inside of node 1 folder there. So that's where all of the data, all of the log files are going to be stored. That's also where all the backups are stored. If you don't specify any location for your backup files, they all get stored in that store location. The listen address is the address that this particular node is going to listen for connections on. Obviously, it's a local laptop, so we're going to use localhost, and I'm specifically listening on the default port of 26257. The HTTP port, which we will also go over a little bit later, that just enables me to hit a website to access our DB console or our administration UI, which we will also run through as part of the demonstration. The join flag is probably the most important flag in all of these flags that we've specified so far. These are the nodes that any new Cockroach DB node being added to the cluster will go to establish a gossiping protocol and basically establish itself as a new node within the cluster. So these nodes then broadcast things like system ranges to make sure that node, the new node getting added, gets all the information it needs to successfully join that cluster. The background flag is the easiest one. That just allows me to use the same terminal window to run all of these commands rather than tying up multiple terminal windows. So it's going to run as a background process. So let's get started and run the first command. So I'm going to go into my binary folder and I am going to run this. It'll take just a couple of seconds to actually complete. and then we will move on. Yep. So it says initial startup is completed. Now, the important thing to wait is it's waiting now. So it's not actually a cluster because we need more nodes to join this one before it becomes a fully successful cluster. So let's do that now. So again, with this one, you'll see that it's exactly the same sort of flags, but because I'm using my local host, I have to listen on different ports for the different nodes. So let's add the second node into the cluster. Here we go. That's the second one. And again, it's completed. So that's good. Now let's add the third one. There we go. And that one's completed successfully. So now we have 3 nodes that have been started, but have not yet begun gossiping between each other because we haven't told them to do that yet. The reason we have to do this is because you could want to set up multiple nodes. In this case, we're setting up 3 nodes, but you could want to set up 5, 7, 9, 15 nodes if you wanted to. So it's just an easy way of sort of getting all of the nodes up and running and then telling the cluster, okay, I'm ready for you to start gossiping and then become an active cluster. So to initiate that command, there's a command in Cockroach called cockroach init or initialize. And you only have to run this once when you establish the cluster for the first time. If you add any new nodes after you've run the init command, they will automatically start gossiping because of that join list that we specified. So again, the cockroach init command, you need to pass the insecure flag to say it's an insecure cluster, and you need to point it at any of the nodes that we've just set up. In this case, I'm pointing at the first node, which is running on 26257. So I am going to run that one. And there we go. It says cluster successfully initialized. So that means that we now have a working Cockroach DB cluster, and we can definitely do a number of things to test to make sure that is the case. I'm just going to grab the logs to ensure that it is up and running. And as you can see from this last one here, initialized new cluster, we know that it is actually running. Some of the other things you see in here is just part of the initialization process, like when we enable the storage engine, which we use as Pebble, and it specifies a bunch of paths that we use. Again, most of those going to that store directory. So let's, again, it's all very well good looking at the logs, but let's actually try and connect to this cluster. So I'm going to use the cockroach SQL command. Cockroach SQL is a CLI, a SQL CLI for interacting with Cockroach. And I am going to connect to 26257 node, which is the first node in the cluster. So this should actually put me into a SQL shell, and it does, and I'm connected to the default DB. So I can, in here, I can run my commands like show databases. I can see there's no user-defined databases there, but there are a couple of system databases. So we know we have a working and a successful cluster now. Okay, so what I'm going to do next is I'm going to run a synthetic workload against the cluster. We have an example database called Mover, which is a ride-sharing application. And we're going to run some load against the cluster for about 5 minutes so that we can go through the administration UI and look at the metrics and the DB console now. So this will just take a couple of seconds to initialize. Let me try that again. It's already been initiated. Let me run. Yep, the demo gods are not on my side this morning. So let me just do some quick troubleshooting. And this is actually quite good because I want to show you the Cockroach DB documentation as part of this. So if we go through to the Cockroach DB documentation page, And if we search for workload, so workload is built into the Cockroach DB binary. And this is the thing that lets you run synthetic workloads against Cockroach DB. So for example, if we come down to, let's run the mobile workload here. So I should be able to copy that. I know why it didn't work. It's because I'm still in the SQL shell. So you need to come out of the SQL shell because we're actually calling the binary to run the workload command. And what Cockroach init will do is it will just set up the schema. And then we run Cockroach workload run, and that will actually run the ongoing commands for a period that you specify. In this case, I'm going to go with the 5-minute duration, but feel free to change that as you guys require. Yeah. So while that is just initializing, I'm going to pull up the DB console for you guys to have a look at this. A couple of seconds while that loads, guys. So there we go. The initialization piece is finished now. And there's the DB console. So there you can see my 3 nodes. And we'll do a quick whistle stop tour of the DB console. I'll just do it for the binary because it's exactly the same whether you use Docker or Kubernetes as well. But if you haven't seen the DB console before, it's very, very feature rich. So you can dig in here and you can see things like, you know, all different things about the single nodes themselves. Where most people concentrate on is the metrics. So before we go into this, let's run the workload and you can start to see some of the graphs in this case. So there we go, and it's starting to generate. So what I'm expecting to see now is these queries per second to start ramping up because now we're running queries against the cluster. And the SQL statements, the CPU profiles, things like that, you'll start to see things in these metrics, dashboards, and graphs. So from the metrics page, as you can see, at the minute I'm looking at the entire cluster, but if I wanted to drill in to see what individual nodes are doing, I could definitely do that, and that's not a problem. And there are also a number of built-in dashboards. So the one we're currently looking at is the overview. And from here, I can see SQL statements. I can see things like service latencies. And these are the things that we would consider as an overview then. So table stakes when looking at your cluster. If you wanted to dig into more granular details, there are a lot of other dashboards. So again, hardware is a common one where we look at the CPU print, the memory print, the disk, and the network IOPS and things like that. And then we get more specific with things like storage. So if you want to see things like the log commit latency, and as you get more familiar with Cockroach and start potentially debugging issues, these are the graphs that you'll want to use to start to tie down some of those issues that you come across. Replication is another good one. This will specify, you know, how many leaseholders per node, for example, how many replicas we're storing on a node. And as you can see, as I start to write data and it gets replicated, it should uniform out because the default replication factor with Cockroach DB is 3. So I expect 1 copy of the data on each of my nodes. And as you can see, that is the case from 12, 13, 20 there. So that's really, really useful for giving you high-level overviews and allowing you to drill deeper into the metrics that Cockroach exposes. Another really useful one is the databases. So if I want to see the schema of the database, so as I mentioned, Mover was one of the ones that we are using. So if I want to see so those are the tables in Cockroach, in the Mover database in Cockroach. I can go in and I can see the create tables for them. I can see all the constraints. If you were to practice in multi-region setups, you will also see the placement constraints in here as well. You can also see the permissions on the tables via grants if you're running in a secure cluster as well. SQL activity is a good one, and this is where a lot of developers will spend a lot of time. So we have sessions, and this is everything grouped into a session. So I only have one session that is connected to this cluster at the moment, and that's what you're seeing here. Transactions are details on the transactions that you will run. So a transaction could contain a number of different SQL statements, and they will be grouped together inside of a transaction. So that gives you a lot of really useful information around, the number of rows read, the typical things we see when we're trying to performance tune problematic SQL queries. Where I like to spend a lot of time is in the statements page. So these are statement by statement queries that we run against the system. So if we take this top one, for example, select from vehicles. So we're selecting city ID from vehicles, where city is a parameter that we're passing in. What I really like about this statements page is it gives you a lot of information as a developer to tune my queries. By that, I mean, if I wanted to see an execution plan, I can see my explain plan here, and it tells me exactly what the explain plan is. If I want to break that down into execution stats, how much time is being spent on the pass, the plan, the run, is there any overhead involved? All can be done from here. If I need a lot more granular details, like if I wanted to know what sort of statistics are in place, what histograms are in place, things like that, if I wanted to get Jaeger trace files and things like that, then I could enable this diagnostic here. And what this will do is the next time that query is run, it will create a zip file of pretty much every piece of information that I would require to diagnose and performance tune a problematic query. So super, super useful screen there. Network latency is going to look rather silly on this one, because obviously it's a local implementation. But if you do this across a network of nodes, then this is really useful for identifying where your network latencies are. So what this says is, for example, the network latency between node 1 and node 2 is 0.34 milliseconds. Node 3 and node 1 is 0.33 milliseconds. So it gives you an idea of, again, network diagnostics, things like that. So the next screen we're going to look at is jobs. And what jobs are things like schema changes, backups, typical jobs you would think of that would require us to track those for completion purposes. And then we have a lot of advanced pages, which is beyond the scope of this webinar. But our documentation does have really, really good documentation on each and every single one of these advanced reports that you can run, or advanced debugging options. So that was a quick whistle-stop tour of the admin UI, or the DB console as it's now known. Let's get back to the demonstration. So that was good timing, 5 minutes, and the workload generator has now completed, which is good. So now what I'm going to do is I need to clean up the local cluster so that I can use the same ports for the Docker binaries and things like that. So I'm going to just run cockroach quit for each of these nodes. So there we go. That's the first node gone. That is the second node gone. Third node. So the third node can take slightly longer to sort of clean itself up, and that's because that's the node that has to do all of the decommissioning of the system ranges to make sure that you're shutting down the cluster in a safe manner. So what I am going to do now is I'm going to pull this one off to one side, and we will create another terminal window so that we can continue. There we go. Make this bigger so you guys can actually see what's going on. There we go. That's it. Okay, so the next thing we're going to do is we're going to do exactly the same that we did with the binary, but instead we're going to install this in Docker. So I have a folder called Docker, and I'm just going to switch my folders over here. So there we go. So the first thing we have to do when installing Cockroach DB in Docker is we have to create a network for the Cockroach DB nodes to use and be able to communicate across inside of the container network interface. So in order to do that, there's a command called docker network create. The D is the background job, and I'm creating it as a bridge, and I'm calling it RoachNet. So I'm going to run that first of all. I hope I have remembered to start my Docker instance. Yes, I have, which is good. So now if we run docker network ls, I should be able to see that Docker network that I just created. And I can, there it is on the bottom there. So that's good. Now we know we have a Docker network that we can use. Now, when using Kubernetes or when using Docker, because they were predominantly built for stateless applications, we have to have a way to persist state for our data that we're storing inside of Cockroach DB. So in order to do that, I create in Docker what we call volumes. So I'm going to create a volume for each of the nodes that I plan to create. And in this case, I'm calling them Roach1, Roach2, and Roach3. So I'm going to go ahead and do that quickly, or as quick as my computer will allow. Third one, and then the spend. So again, I'm going to check to make sure that those volumes have got created with docker volume ls, which will list all the Docker volumes created. And as you can see, I have Roach1, Roach2, and Roach3 created there. So the next three steps are going to be create the Docker containers for each of the nodes that are going to run Cockroach DB. And you will find that it is very similar to the way that we started each node when we did the binary implementation of this. So again, Docker run, I'm giving it a name for simplicity purposes. The host name is important so that I can reference that in the join strings. I'm giving it the network that we're going to use. And then I need to do some port mapping to ensure that we are exposing ports correctly for the gossiping protocols, for the client access, and also for the 8080, the admin UI as well. This -v command, this is the part where I'm mapping those volumes that I created in the previous step to an actual physical directory on my computer. So as you can see, Roach1 is going to go to Cockroach data in this case. The next flag is the version that I'm actually using, and those keen of eye here will know that I'm using an older version of Cockroach DB. That isn't by design, that is just when I created these scripts. That was the latest version that I used. So if you guys want to swap these out for the latest version, which is 21.2 at the moment, you're more than welcome to do that. Again, insecure cluster. Again, for simplicity purposes, I don't want to have to deal with creating certificates for development environments and things like that. So I'm going to start this in insecure. And my join flag, slightly different to the binary where we were referencing port names and IP addresses. Now we're able to reference the names that we give, or the host names for the Docker containers themselves. So I am going to run this one to create the first Docker container. I do see a couple of questions popping in, guys. I will definitely leave time at the end so that I can answer those questions for you. So that's the first one. And then we're going to do exactly the same with the second Docker container. the 3rd. There we go. So that's all 3 Docker containers that have now been created. And for completeness, let's just check to make sure that we have 3 Docker containers. So we do. We have Roach 3, Roach 2, and Roach 1, which is good. So if you remember from what we had to do with the binary, we also now have to initialize the cluster. So for this, it's the same cockroach init command, cockroach init insecure. And the way that we do it with Docker is we just create an interactive terminal to the Roach 1, in this case, container, and we run the cockroach init command. So I am going to do that. There we get, it says cluster has already been initialized, failed to run init. So that means we have an initialized cluster, and we can check that by grepping the nodes. There we go. It tells us our cockroach build, gives us the port address for the web UI, gives us your SQL connection if you want to connect via SQL. So that's always a good thing to do. I will share these scripts, and they are on my website, so we will include links to that afterwards. I always recommend that you do this and capture this information because it's super useful to give to developers and things like that when they want to connect to the cluster. So let's get an interactive shell to Roach 1. There we go, and we're into our SQL shell again. So there we go. If we do show databases, there it is. So we have a fully working Cockroach DB cluster now in Docker. And that's as easy as it is to get a Cockroach DB instance running in Docker. Again, I'm going to clean up here before we move on to the Kubernetes one. And then I will get round to questions at the end. How are we doing for time? 12:30. Yeah, we're not doing too bad. Just give me a couple of minutes to clean these up, and then we can we'll move on to Kubernetes. So I'm just stopping the containers first of all, and then I'm going to remove each of the containers. I'm going to remove the network that we created. And I'm going to remove the physical directory on my computer that stores the cockroach data. So there we go. We're all nice and clean now. So we've done the binary and we've done the Docker container. So I hope you guys can see that there are not too many differences to the way that you create nodes with Cockroach, and then when you initialize a cluster. There are similarities between binary and Docker. It's just the orchestration tools that you're using to start Cockroach that will differ. So let's move on to Kubernetes, and this is predominantly where we see, I would say at this point, 80% of our clients looking to deploy Cockroach. They're looking at Kubernetes for building new microservices and for all of the benefits it offers in terms of self-recovery, scalability, and it knits quite well with Cockroach DB's scalability and resiliency as well. So it's definitely a good thing to consider. What I would say is I would only ever deploy Cockroach DB inside of Kubernetes if your applications are also deployed inside of Kubernetes. I wouldn't deploy Cockroach DB inside of Kubernetes if your applications are not there, because that just adds a whole lot of complexity around networking that you have to deal with. So let's crack on with the demonstration, and then we can get around to some questions at the end. So the way that we deploy Cockroach DB, or the way that I'm going to deploy Cockroach DB inside of my Kubernetes infrastructure, is via YAML files or stateful set configuration files. There are other options available to you. So you can use Helm charts, for example, to deploy, and there is also a Cockroach DB operator. However, stateful set YAML files are probably the most configurable and the most widely available that can be deployed across any Kubernetes distribution. So that's the one that I chose to go with today. Before we get started, I'm just going to take you through the stateful set file itself. I'm going to expand, and again, you'll see a lot of similarities in terms of the Cockroach start command. For those familiar with Kubernetes, a lot of this will make a lot of sense. So again, we create a service in Kubernetes so that called Cockroach public, and that's how all connections into the Cockroach DB cluster is instantiated. And we're doing some port mapping, again, 26257 for SQL traffic and gossiping traffic, and port 8080 for the admin UI. I'm not going to go through taints and tolerations and things like that. What I want to get into, the pod disruption policy is important. Excuse me. So what this actually says is the max unavailable Cockroach DB pods is 1. So if you want to upgrade your cluster, for example, it will do it in a 1-by-1 fashion. It will only allow one node in your Cockroach DB stateful set file to go down at any given point in time, hence keeping the resiliency factor that you're familiar with. So the stateful set file itself, this is where we control how many replicas, so how many pods I want to deploy Cockroach DB to, essentially how many nodes in Cockroach we can have running. Again, I'm going to keep it consistent at 3. If you guys want to play around with this and have 5 nodes, 7 nodes, as long as your infrastructure is able to support it, then go ahead. The containers themselves, what I'm doing is setting resource requests and limits. So I have a fairly beefy laptop with 16 cores here, 32 gig of RAM. So I'm giving each Cockroach DB pod 2 CPUs and 4 gigabytes of memory. And the version of Cockroach DB I'm using is specified in the image file. Again, a lot of this is health readiness checks. Again, we're mounting volumes here. So one important thing to recognize if you're using Kubernetes is we highly recommend that you use persistent volume claims and persistent volumes to persist your data to disk. That is for efficiency purposes more than anything. So if you did lose a pod within inside Kubernetes and it spins up a new pod and self-heals itself, it's very, very easy to move the mounts between the different containers that get deployed. So the Cockroach start command, again, here it is. As you guys can see, very, very similar. The only difference with this one is I'm logging to standard error, just in case. The insecure flag you're aware of. Advertise host is similar to the listen address in that we're advertising the host name in this case, and the join flag is the Cockroach DB nodes that get joined to the cluster. So Cockroach DB 0, 1, and 2, which are specified further up in the stateful set file. And the bottom bit is where we create the statement, the persistent volume claims for it there. So in this case, I'm instantiating 100 gigabytes for my cluster. So that's just a quick run through the stateful set files. Now let's go ahead and deploy Cockroach DB into Kubernetes. So the distribution of Kubernetes that I'm using is Minikube. I did start the Minikube cluster prior to the webinar starting. It has 16 vCPUs of RAM and it has 16 CPUs and it has 16 gig of RAM to be able to use. So we should have plenty of resources to deploy Cockroach. So the first command is I'm going to use kubectl. So first thing I always do is I do kubectl get namespaces to see what namespaces I have available. So default, so I know I have an active Kubernetes cluster. I then do kubectl get pods -- all namespaces so that I can see all the pods running in all the namespaces. So I'm not expecting to see any user ones here because this is a fresh Minikube cluster and I see all system, which is good. So let's deploy the stateful set file now. and wait for that to complete. So there we go. That has been created. Let's do a get pods. Okay, so what we're waiting for now is the status column to become running. These pods will never become ready until we initialize the cluster, similar to what we did in the previous 2 deployments. So I'm just going to run get pods a couple of times until we see this as running. For you Kubernetes experts, yes, I could run the -wait command, but I am a very simple person, so I'm going to keep running get pods until I see the status is running. And there you go. So I have 3 pods that are all up and running, Cockroach DB 0, 1, and 2. They're in status of running, but they are not yet ready because we haven't initialized the cluster. The other thing that I always check is the persistent volumes to make sure that they have also been created as part of the stateful set. And I can see that I have 3 volumes created there, which is awesome. That's exactly what we wanted to see. So next thing I need to do is initialize the cluster. I'm going to do a create, which creates this cluster from this cluster init YAML, which is available in our GitHub user content repo. You can download this file as well if you want to. It's a very simple file that simply spins up a pod and runs a Cockroach DB init command against one of the pods within the cluster. So I'm going to initialize that cluster using that command. And it actually creates a job called cluster init, which allows us to track when that's been completed. So if we do cluster init, yeah, just waiting for it to complete. And we can also do get pods to see the pods becoming in a ready state as well. That'll take a couple of minutes to do. So, job's completed now. So if I do get pods, there we go. All of my Cockroach DB pods have now switched into a ready state. And we have an active Cockroach DB cluster at this point. To prove that, let's create a test pod. So I'm going to run kubectl run here with an interactive terminal where I'm going to spin up a client and run Cockroach SQL. There we go. So I have now a SQL shell, and let's do the show databases command to prove it. There we go. So there I have now an active running Cockroach DB cluster inside of Kubernetes very, very easily. So I hope you guys can see that within 35 minutes of this webinar, we've been able to deploy 3 Cockroach DB clusters, one using the Cockroach DB binary, one using Docker containers running locally on my laptop, and the third using an orchestration tool called Kubernetes. In this case, it was Minikube was the distribution of Kubernetes that I used, but all very, very easily deployed very, very quickly in terms of Cockroach DB. Okay, so that leaves us about 10-15 minutes for questions. I'm going to stop sharing my screen at the moment, and I'm going to go through the chat and the QA panel for questions. So let me just pull up the QA panel. So if I run Cockroach DB on DigitalOcean, how much RAM and CPU do I need? I seem to recall that 4 GB of RAM is recommended per node. Yeah, so for development purposes, you are more than welcome to use 2 vCPU or 4 vCPU nodes. We really recommend 4 vCPU nodes and 8 GB of RAM for most test deployments. When you move to production, the minimum sort of CPU and RAM footprint that we like is 8 vCPUs and 16 to 32 GB of RAM. Why do I have Postgres database on my machine? So Cockroach DB is Postgres compatible. So we are capable of using the PG wire protocol from an application perspective. And we have a lot of similarities with Cockroach DB codebase in terms of the SQL syntax that we use. Hence, when you deploy Cockroach DB, you have Postgres as a database platform, database inside of Cockroach DB. 1 to 3 of databases, default DB. I don't think that's really a question, that's a statement. So do I need to run Cockroach in it just once for the cluster or each time when the cluster starts up? No, you just need to run it once. Once you run it once, it pretty much puts a flag in Cockroach to say that this is an active cluster, and all nodes participating in that cluster will then gossip between them. That's even if you take nodes down, bring them back up, even if you add and remove nodes as well. You don't need to run Cockroach init more than once. You just need to run it once on initial instantiation of the cluster. The default DB database would be created by default. So default DB database is created by default, and that is when most ORMs, most application frameworks will connect to default DB as the default database if you don't specify a database as part of your connection string. So that's all of the questions answered. So look, do I need one more come in? Have you used Rancher with Cockroach DB? Yes, we have. Cockroach DB is in. You can deploy Cockroach DB independent of Kubernetes distribution. So we've seen clients run on top of Rancher, GKE, AKS, EKS, lots of different sort of orchestration distributions there. So yeah, Rancher is not a problem for us. We have people on our team that have extensive experience of Rancher as well. So there's definitely something good to know. I'm going to switch over to the chat and see if there's any in the chat. Insecure, you are limited, for example, you can't change your password. Yeah, so if you're running in secure mode, you're right. The cluster is wide open. There is no security implications in terms of being able to add users, passwords, things like that. Same with certificates. You can't use certificates on an insecure cluster. If you require any form of security privileges, then please start your cluster in secure mode and follow the documentations to set that up correctly. Can I send out my notes? Yeah, when JP publishes this on YouTube, I will give him a link to my website, which has all of the code on it for you in a nicely formatted way, so that you can have all of these slides. There was just 3 slides at the beginning with literally no content on, so I don't think we need those. Leave the SQL terminal running this command. Don't know what that means. Could it be that you're still in the SQL shell? Yeah, that was the case when I tried to run the workload generation. It was because I was still in a SQL command. So that's a very good catch there, Carsten. I missed the first part. Are you running this on your local machine? Is it Linux? So yes, I run all of these on my local machine. I use Mac as my local machine. But a lot of these commands will be exactly the same, whether you run them on Macintosh or whether you run them on Linux. They will be different if you run them on Windows. If you do run them on Windows, I highly recommend you install WSL or the Linux subsystem for Windows. You'll have a much easier life in deploying Cockroach on top of those infrastructures. The first one was in local machine, now on Docker, and the third one was in Kubernetes. So in terms of performance, there is always overhead when you use orchestration tools like Docker or Kubernetes. So highly recommend you guys test your applications, your workloads, things like that, to make sure they are performant. I often get asked, what is the typical performance overhead? And it's very, very difficult to answer because it's not only dependent on the orchestration framework you use, it's also dependent on the underlying hardware that you use. But I wouldn't expect to see much more than a 3 to 5% performance overhead of using one of those orchestration deployment mechanisms. Are you all going to support ODBC driver? We are looking at support for ODBC. I don't know where we currently are with that. I need to check in with the PM teams to find that for you. Did you use Docker Desktop for the Docker installation? I did use Docker Desktop for the installation, so that is something that I am using. How Cockroach DB is different from DBs like Snowflake or Redshift. So Cockroach DB is a transactional SQL database built very much for OLTP workloads. Redshift and Snowflake are more MPP type databases and are better fit for OLAP or analytical type queries. Okay. So if you're doing any heavy analysis, any heavy analytics, if you're doing multi-dimensional modeling of your data and things like that, then you're better off going with Snowflake and Redshift over Cockroach DB. However, if you need very high level of transaction throughput, you need consistency of the data, then Cockroach DB is a much better choice than Snowflake or Redshift for those workloads. How does Cockroach DB keep track of the records that need to be caught up by replicas? Is there a temp file maintained for this purpose? In this information captured in the region, you understand. So Cockroach DB piggybacks its replication and distribution protocols off a distributed consensus algorithm called Raft. So anybody done anything in the distributed algorithm space, they will know that there's ultimately two distributed quorum-based algorithms that are in play. One is Raft, one is Paxos. Raft is the easier of the one to understand. So the way it works is by using Raft logs that each node is aware of. And we piggyback everything off that protocol. There are a number of webinars that we've done in the past that will explain Raft and how we do distribution and replication inside of Cockroach DB. Is there any way to see if my Postgres queries will work on Cockroach DB apart from just running them? That is the best way to cast them, if I'm honest. That's the way that I do it. I run them against Cockroach DB, and the latest versions of Cockroach DB will actually be very helpful in telling you what Cockroach DB doesn't support and how you could potentially refactor those to work with Cockroach DB. If I run Cockroach DB straight in Linux, what's the best way to back up my data? So you can use the Cockroach DB backup commands. You can there's built-in backups, full backups are in the community edition. If you need incremental backups, then that's where you look at the enterprise edition of Cockroach DB. But you can back up then to things like S3 storage if you're using cloud providers. Any S3 compatible endpoint you can back up to, or you can use local storage as well. So if you've got local storage, you can back up there. It's very much dependent on your business continuity plans and what's available to you and where you can back up your files to. If I run Cockroach DB straight in Linux, I've answered that one, the backup ones. So when the leader node leaseholder for a particular range goes down, whether read or write for that range get blocked momentarily. Yes, that is correct. So every range inside of Cockroach, and a range is just a 512 megabyte block of data. So every range will get a leaseholder. And if something happens to that node that the leaseholder is on, for example, every 9 seconds, we do a leaseholder check on all ranges in the cluster. If we establish that that range doesn't have a leaseholder and it's not available, we will move the leaseholder to the next available node. And that's why it is super important when developing applications against distributed databases, not just Cockroach, but any distributed database. Two things are very important. Always try and get retry logic into your application. In that example, 9 seconds pass, new leaseholder gets elected, your application retries and is successful, so there is very minimal downtime there. The RTO of Cockroach DB is 9 seconds for that reason. The second thing is to make your statements as idempotent as possible. So when you run the queries multiple times against the database, it gives you the same results. Cockroach DB versus Postgres cluster. Cockroach DB automatically distributes all the reads and writes across all nodes, unlike many Postgres cluster options, correct? So that depends on what you specify the replication factor in CockroachDB to be. So I'll give you an example. If you have 3 nodes and you set the replication factor to 3, then CockroachDB would put 1 copy of the data on each node. However, if you have a 5-node CockroachDB cluster and you keep the replication factor of 3, then we would put 1 copy of the data on 3 different nodes. So there will be two nodes that don't have a copy of the data on. What happens in that case is if you lose a node with a copy of the data on, after 5 minutes, CockroachDB will recognize that you're under-replicated. There will be no impact to the application in that 5 minutes because there's still 2 available copies of the data, so you can get a quorum. But what will happen after 5 minutes then is we will do a process called replicating, which will put a copy of the data on a node that didn't previously have a copy of that data, hence always keeping the 3 times replication factor and maintaining the resiliency that you guys specify. As into Postgres, Postgres is typically synchronous, asynchronous with a number of read replicas. If you apply sort of distributed concepts to Postgres, you have to do things like conflict resolution if you're doing multi-master write nodes in Postgres, which gets very, very complicated very, very quickly. I think that answers all of the questions that I could find in the chat and in the Q&A box. So I think we will call it quits there today, guys. Thank you very much for attending the webinar. Again, the recording will be available via YouTube and the CockroachDB website, and I'll make sure you guys have full access to all of the scripts that I've used through the webinar today. So thank you very much all, and I shall catch you all on the